Should we get started? Hey guys.
Hi, I was wondering if call happening today because of US holiday.
Oh yeah, it is the US holiday today. So we might be a little late.
Hey Ivan, like the new style?
Yeah, I'm joining the club. After working some time on Grapplay, everyone lose their hair. It's like it's a symptom.
Okay, so the first thing that I wanted to do is I think the discussions that I have in the repo are a bit outdated now that we decided on the new response format. So I think that I'm going to post a new discussion that's basically like copy paste that explains the response format we've been discussing. Say that like this is the direction that we're going in now. I'll leave it open if anyone wants to suggest tweaks or anything.
Quick question. Can you send a link on what's the latest? I missed like last call, and I have access to recording thanks to Benji, but I didn't have time to watch it. So can you send just thanks a lot.
Yeah, it's the gist that's at the gist, not any of the comments. We talked it through with Matt, and I think that his concerns have been addressed now. So the plan is to go with what we've been discussing for the past few weeks in this at the top of this gist. Yeah, so I'll post a new discussion topic that has like all this info. So anyone who's following that repo can see it. And if anyone has concerns or suggestions, we can work through that. I'll also go through all of the any of the unresolved discussions that are open that may have been resolved by this. There's a few from Benji about duplication, all that stuff. So I'll make sure that those are. I'll leave a comment that they're addressed and mark them as resolved. And yeah, and then I'll go through again and I'll see what is still an open issue that we need to go through.
One quick question. Does anybody working on, like, because we discuss a lot of denial of service attacks, increasing payload and everything. Does anybody working on analysis of current proposal, if it's can be attacked, and what should server check, and what would be reasonable, what you should apply limits on, stuff like that? Is it I think somebody need to go through it and outline what is denial of service vulnerable and what's not.
Yeah, maybe I can make like a comparison between this new format and the old one and show how like the deduplication with the old one, basically like you could like amplify the request payload size exponentially, maybe more than that. But with this one, I think that it grows at a much more constant rate because it's really only the sending more longer paths multiple times now. So I can like write up an example that demonstrates that. As far as like limits, I had a discussion open for a while. Yeah, this is old. And I think I mean, I'm not really sure like if we could like concretely say like a server shouldn't allow more than like X defers or something. But I think that we should have some language that says that there should be some kind of limit and leave it up for the implementations to decide.
Yeah, we
Yeah,
can
basically.
suggest limit. It's like without my suggestion was that like we can without analyzing proposal too much. It's a question. What should you limit? You should limit like number of defer groups. You should limit number of fields under defer. You should number like defer on different level, or if like defer on the same level, it's merged, so it's like number is not. So point here is like if we want people to implement it or like evaluate it in reasonable fashion. So part of package deal is to have like so at least suggestion what should be limited. Like
Yeah.
for example, which if we do merging, it should be like a number of different levels on which you have like differs, so like something like that, or like so I didn't look through, but yeah, some suggestion. Oh,
Yeah. What I'm most worried about is not like the number of fields that are being deferred or the number of levels, but just specifically like the total number, which could grow a lot if you are deferring inside of lists or list of lists or something like that. That's so we should make note of that. And yeah, and Benji did this really good write-up about the topic of early execution and made some cases explaining that. I don't know if everyone had a chance to read through this. Yeah, so my thoughts on this, in my server, basically like we only load data through API requests and we don't have any kind of queues. So it's not like we wouldn't see this issue. And so I am concerned if like if I was like forced to extend like the total time of request, like everything that was deferred was requested later. There's not like too much benefit for me to do that. So I'm hoping that, so like my suggestion was that if we come up with some kind of way that could let an implementer choose if they wanted to, like give them a way that they could delay the resolvers instead of like directly forcing the execution. But yeah, want to hear everyone's thoughts.
Just to just to challenge that, Rob, are you sure that there's no queue in your HTTP fetching? It's very common for systems to put in place limits on the number of concurrent fetches that are allowed, the number of concurrent network requests, things like that. It may not be as explicit as the example that I've laid out in this example, but it's very common. Certainly web browsers, for example, in HTTP 1, limited to like 4 connections per domain or something small like that. That's not like something that you really configure or think about, but it is something that exists in the background.
Yeah, totally. It's definitely possible. But I do know that we have like a lot of very large queries that make lots and lots of requests, and we have waterfall charts for them. So if there is that type of limit, I think it's pretty high. But yeah, I mean, it's definitely possible that even with API requests, other people will have queues.
One question. Yeah, related to question I asked in my comment. Basically, there is like a resolution stage, completion stage, and delivery stage. So like, we can say implementation at minimum should defer like delivery, but everything else is up to implementation. Question here is like, is it visible to a client or not? Like, can client figure out if delivery just deferred or if like completion deferred? Not like performance wise, otherwise like without timing. Does this like change in semantics change like perceivable result for client? Yeah.
I don't think it would.
So we're discussing basically standard algorithm and standard implementation, or we're discussing like requirement from a spec. Because for requirement, we need to make thing rigid. We need to explanation why it should be like rigid for client. So
I don't think anyone was suggesting that the spec make the requirement one way or another. Like, I think that I was thinking that the spec you should write the spec as if it's doing early execution, but have a note that an implementer can delay as long as it wants. And that could be by 1 tick, it could be some amount of time, it could be all the way up to what Benji proposed of the maximal option. And I think, and in Benji's, he, in the original post here, he said that like, even if we spec the fully deferred execution, it doesn't mean that early execution isn't allowed. It's because you could still like, you could write something with early execution and you still get the same results, and that's allowed by the GraphQL spec. But there are other things that you need to keep track of if you're doing that, with regards to error bubbling, and I think it's just error bubbling, but yeah, did that answer your question?
like, how error bubbling is changing? Because like, imagine like we call resolver, and resolver can immediately throw, but it can like promise can be rejected. And in both cases, like, either if we delay execution, delay calling to resolver, or resolver rejects, we will have the same result.
Yeah, here's the example. If you have this query, this is a non-nullable field that's going to error, and this is just a regular field. If there's no defer here, then when this gets executed, foo for value completions waiting for both to finish, it's going to see that this one errors, that error is going to bubble up, and you get a result of foo null. If you're doing deferred execution, then you're going to execute this field. This field's not even going to start executing until this one's done. You're going to see that this nulls, that bubbles up, bar never gets executed, and foo gets returned as null. If you have early execution, you start executing this field. Now you start your deferred payload executing bar. That's in whatever queue you have of future payloads that need to be delivered. This one errors, bubbles up, you return foo null in the initial payload. Now you need to make sure that that deferred payload that has bar doesn't get sent to the client, because it's going to be pointing to a location that doesn't exist. So because you have this in its own, because by the nature of defer, you have this pointing to its own new payload, you have to make sure that you're not sending things that don't have a path to place them in.
There's also bigger problems with this as well. So for example, in this same situation, imagine that this was instead a mutation operation, and someone was implementing the pattern of nested mutations, which people shouldn't do and isn't something that we encourage, but we don't, I think, strongly discourage it in the spec, though I think we should. So if these non-nullable field, the errors and bar are both actually fields that have side effects, i.e. mutations, then in the deferred execution model, bar will never execute because the other one threw. But in the early execution model, bar will execute anyway, even if non-nullable field the errors throws. And that means that the result of this would change, the side effects that happen from this would change depending on whether we do early execution or not, or deferred execution.
Doesn't this happen today with nested mutations? Is if this is a mutation, only the top level fields get executed serially, right?
Yeah.
Yes. So it does happen today with how they're done, but if you wrap a thing in defer and the spec says that the defer means that it won't be executed until afterwards, or the user who writes it expects that, then it's a concrete change in behavior between early execution and deferred execution. So we state that whatever the spec says, people should adhere to that, and you can do another algorithm so long as the result can't be determined by the client to have been different. And though the payloads that you'd receive would be the same, the actual side effects that would have happened would actually be different between the early execution and the deferred execution cases.
So if we do deferred execution, that would give a way for people to write nested mutations that are expected to execute in serially under the first level. That doesn't exist now. Is that what you mean?
Yeah, I guess that's true. Yeah. And you could then nest more under more defers if you wanted to.
Well, that would be a new feature that we could just warn people doesn't exist.
Yeah, I don't think that's the intended purpose of defer, and I would hope that that's not the takeaway that happens.
Yeah, what I think personally is that with resolvers, any type of optimization can happen, and if you rely on order or something outside of top-level mutation, it's your own issue with you inside particular implementation. But about errors, I actually I thought a bit about it, and I actually think error boundaries should be predictable, meaning even if we do early execution and synchronous part throws of early execution. So like in this example, let's say like non-knowable field is not thrown, but bar is thrown. And it can throw in two ways. It can throw in synchronous part, or it can throw in, it can reject a promise. Depending on that, in early execution model, result is changing. So I'm for describing it like that. Basically, stuff that you defer always don't blow up like things. With caveat, if defer is inlined, everything is work as usual. If defer is not inlined, even if it's like executed earlier or later, stuff is predictable. Stuff is like initial part of get shipped and doesn't blow up by deferred parts, even if resolver is started synchronously.
I think that that's handled. Like, we're not going to see a difference in results if a deferred field flows up synchronously or asynchronously. That's all handled. You'll see the same result, and we have examples of that. I mean, we don't have specific. There's definitely a time where that wasn't the case, and I thought was just a bug that we had fixed. So, but we have examples of null bubbling inside defers and how we're handling that in the gist. There's examples in here.
Okay. So
yeah.
To summarize, we're just discussing like behavior of calling resolver. We're not discussing like user visible stuff. We're discussing like if something blow up, if with another resolver of default part gets called or not.
Yeah. And yeah, so it's basically like, so I think there's two ways we could write the spec. You could write the spec that says there's early execution, implementers can delay it. You could write the spec that says it's deferred execution, implementers can execute things sooner, but they have to make sure that the results are exactly the same. Right. Now, I was arguing that we should do the, I think if you do the deferred execution spec algorithm, things are simpler because you don't have to handle cases like this null bubbling. It just works automatically because the deferred stuff won't ever get executed until after things that null do. If you do it, if you do early execution, then you do have to handle those cases. And so the spec is a little bit more complex. There's another function that you have to write that anytime a null bubbles in this path, you have to go through and check the deferred payloads and see if any of them should be canceled or filtered or something like that. And so I think I was arguing that that's what we should do, because I think that even if we do spec deferred execution, a lot of implementations are going to want to implement early execution. Personally, that's what I would want from my server. And I think that like you should just have all the details in the spec of what needs to be done to do that.
Wait, and you say like people would want it because like I see like 3 different performances: performance of like the whole query, performance of a server, and performance of initial part. So from performance of initial part, it's a little bit preferable to defer execution. So like initial parts is guaranteed to not work on anything, and even synchronous part of deferred stuff is not executed. So like you get initial stuff sooner. Server performance is not affected in any way, like throughput, it's the same. If it's
Well,
you run
I think it actually could be, because you could have, it means that your entire connection is longer lived. So you could have more concurrent connections if each request is taking a longer time.
Okay. So what's your argument for wanting early execution? Is it like with number of connections, or you want user to see like loading faster?
Yeah,
like
it's both of those. I would say it's both of those things.
Okay, but you think risk of delaying initial part is not there, right?
Yeah, I think the risk of delaying the initial part is certainly there, but I think that it's negligible at least in my implementation.
Okay.
Which is just using GraphQL JS, and it doesn't like directly connect to databases, but it uses it gets all its data from API calls.
Well, so first of all, hi, and second of all, I think this is a really really interesting issue, because meaning even if meaning we have no way. Benji was is really pointing out something tricky, because we have no way of knowing how these things will queue downstream. So if you potentially are sending a API call to a particular server with some fields for the initial result and then with some deferred fields, and that API then will be hit by both of those things at the same time, and it could get the deferred fields first, potentially, because even though it waits a tick, it's things in the initial result, further down the tree could be started after a deferred field with early execution. So even though we think, we're calling out to other APIs, if we're calling out to the same API at any point, we could hit Benji's issue. So so it's a tricky one to say for sure it doesn't exist, no matter the graph, unless we're always sure that when we call out to things, they are working off of completely different databases at all times. So I think it definitely could use some real world testing.
Yeah, definitely agree. We don't know how things queue downstream, and but when you get to that point, couldn't you also have an issue where, like, if your deferred calls are stretched out longer, then the deferred part is like being sent later. That's like also being sent concurrently with other requests that may not have defer in it. I don't know. I think it's really hard to model. Like,
Yeah, I think that's a really good point. Meaning, how different would this be than a very busy server? So if you have a very busy server hitting the same, really lengthy calls, and and it's able to handle that well, that bode pretty well.
One thing, just what about, and we was Yakov, right?
Yeah.
Yeah, before he reconnects, like quick thought, others are kind of broken by early execution, right? If you use data orders like any action against differs, resolvers get something, and this something is batched. Default stuff batched together with like initial result stuff in the same data orders, batch things of data order.
You're breaking up a lot. I'm not sure if it's on my end. I don't think I could make out totally what you were saying.
I will type.
Anyway, what I'm thinking now is that like I would like to favor early execution, but provide a way for resolvers to get delayed execution. And I feel like that would be implementation specific, but I was saying like maybe there's more data we could put on GraphQL resolve info that lets you know if a field is being deferred. Benji proposed we pass like a promise into there that could be awaited if you wanted to wait until all of the non-deferred stuff happened. That would mean more work for the resolvers that do need the deferred execution, but it would at least give you the choice, because there's no way to like execute something sooner in the resolver, but we could provide a way to delay things.
So one thing that I like about this is it's very easy. It's very easy for someone who finds that they have this problem to work around it by just putting this at the top of every single one of their resolvers. And they could even opt into this, or even pass it as a flag to GraphQL and have GraphQL.js, for example, just do this automatically for you. It's definitely a choice that the schema designer is making at this point. I'm just not sure that the default should be to default to early execution. I feel like you should always opt in to early execution, even if that means opting into early execution globally and then opting back out again on a resolver basis by waiting for the promise.
Yeah, I also support that. I typed my question in the chat about data order. Maybe I'm missing something.
What do you mean by batching from the initial part to the deferred part?
So imagine we have like aliased fields, the same field but aliased.
Yeah.
And some of aliases is initial part, some of them in deferred part. You call data order. Since you do early execution, you basically in the same like tick. So that what data order does is to put them in same array and send it to a server as one batch. So we basically, if we use data order naively, we tying initial result performance to defer performance. So if we speak only about these fields, like just field, I don't know, like doing like hashing or something, not have like something without, you don't have deeper fields, you have just top level field, and resolver use data order, and you use like you have like two field alias. One is initial result, another is deferred. Both of them call data order, put like stuff in the same basket, ship it to implementation in the same basket. So now you're in a situation where data order forces initial fields from initial results to wait on deferred stuff. So even though deferred shipped like shipped separately, but performance-wise, the fourth part is tied to initial result. And I think it would be common in implementations that try to do batching. So easy implementations, not the spec don't care about batching inside the resolvers. So easy implementation need to provide like building or like in a model, GraphQL.js model, where data order separate from GraphQL.js, data order doesn't know if it's code that doesn't know like which calls should be batched separately from other calls.
So, hi, sorry I dropped. So I added into our working implementation something that may help with that, meaning exposing to resolvers the priority that they're running at, and so resolvers could group could group their data loaders accordingly. Basically, I implemented both suggestions as far as I understood them. From that issue. One is exposing to resolvers the priority of the currently deferred field, as well as exposing to them whether the parent has completed, and exposing a promise. If it hasn't completed, exposing a promise that resolves when it does. So they can choose to disable on a per field basis. Whenever that field is deferred, they can choose to disable early execution. It's a little bit tedious to do that for every resolver if you don't want to have early execution, but you could always just simply programmatically wrap every resolver, I guess.
So basically, if we want early execution as default way, we need to have cooperating resolvers, right? We cannot have like dumb, like without resolvers, without any change, work with nicely with early execution.
I think that's right.
So since we adding stuff additively, meaning like people can enable stream defer without changing the resolvers, it means we cannot require cooperating resolvers by default, and it's situation for every implementations like out there.
I'm not sure I followed that last bit. Would you be able to rephrase that?
So like since people already have schema and people already have resolvers, and the update to GraphQL.js 17 or GraphQL Java, whatever, and suddenly stuff work with stream deferred, person is happy, like entire front-end team is happy, they start using defers, and when they discover like weird thing, they basically stuff technically is deferred, shipped in separate payload, but they receive it almost instantaneous. The time difference between initial payload and deferred payload is like non-existent, basically, in some cases. So since your solution exposing stuff to a resolver, but unless we want to resolver or specifically signalize like this field can be resolved, we cannot trust that person don't have like batching data loaders, interlocks, or any other like performance pitfalls. So I would argue that late execution, deferred execution is a way forward, since we retroactively adding this feature without and don't require people to opt in on the resolver level. So people can opt into stream defer on like schema level. They can add, remove directive, do something, but on per resolver level, like you don't have opt-in. You cannot say like.
I don't know. I don't know if I mean, I have to think about it more, but I'm not sure I agree. Meaning, if a server allows defer and stream, upgrades to GraphQL v17, exposes the defer stream directives, clients will get the new format, but they may not get all the potential benefits of defer unless the resolvers, when necessary, are adjusted. Now, I'm not sure in the end of the day, I'm not actually sure whether that interconnection of the initial result and the deferred payload will ultimately lead to a performance benefit that the client, a performance impact that the client won't find beneficial. Meaning, it's sort of tricky. It's not necessarily true that every batching that connects the initial result and deferred payload is going to be like a nightmare scenario that of the very expensive field and the very cheap field. It could be most of those are the cheap, are the same, are just going to overall not add extra latency. So I think it requires like profiling, in particular examples to see.
Okay.
And so what I would argue is we definitely need to explore it, but it might require a sort of generic extension to data loader that is aware of these different queues, rather than and may require some rewriting of resolvers overall. But I think we may find that it basically it's a new feature that the clients won't get the ultimate benefit from unless unless the servers adapt accordingly. So a server may choose to enable it everywhere except where, and then where it sees that it's not beneficial as much as we think it could be, start attacking resolvers and trying to optimize. I think that could be one plan of attack, but you'll never get worse performance than a query that does an operation that doesn't have defer and stream because of this issue. You just may not get all the benefits of that you might expect. But I do see your point. Like, we're releasing a new feature that clients may not see the immediate benefit from. Even if it's no worse than before, we sort of promised it would be better. So that would be confusing. But I'm just not sure how often, if that happened in 99% of the cases, that would be very bad. Just for overall, we'd look foolish. But if it happens in 1% of the cases, then I think clients would, everyone would be happier that it's on, that early execution is enabled by default. So what is the problem scenario in practice? Is it 99%, 1%, somewhere in between that's much closer to one end of the spectrum? Or is it 50-50? I think we need to explore that.
Yeah, question I have, and I just understood that it's enough to have only like one resolver affected. like if you have only one resolver that do like not even data load or something custom, and this resolver is tied between initial result and default result, the whole default result basically tied to initial result. Since we cannot in this proposal, deferred stuff, you should send it in a single batch, right? You cannot say send it field by field. So basically, if you have like a bunch of fields, like initial result have hundreds of different resolvers, and default part have like another 100 resolvers code. And it's enough to have one resolver in initial, one invocation initial result tied to one invocation default part to stop like entire default part from being shipped. So
I agree. It will tie it together for the length of that resolver, but how long, but there are a lot of resolvers, right? So how long will that one resolver be in the vast majority of cases? Is that the very expensive field? If it's the very expensive field that's being batched between the initial and the deferred payload, and they're both equally expensive, and they don't help each other out by being executed as a batch, then I do agree. But I'm not sure that's the most common scenario, where the resolvers that are batched are the expensive ones, and that batching won't overall lead to a result that the client will want. Meaning, I would assume anything in the initial result is not going to be expensive at all. Otherwise, it would be deferred. So a data loader that includes both, basically, to make a long story short, I shouldn't make too much assumptions. I'm just not sure that we can accurately predict without getting some concrete examples. Certainly, I can't. So let me stop speculating.
Yeah, that's why I say we cannot write performance tests. Like whatever test we will write, synthetic test we will write will be biased by person who wrote it and his assumption. So
I mean, I think I see along the lines of what you're saying, you could say we should try to do the most conservative thing possible. But even if we reframe it like that, I'm not sure which one, still what to do exactly.
yes, so like I see it like that. People get like 90% of rephrasing your Pareto law. Basically, my Pareto law is like you get 90% of result performance boost from different stuff. Like use like 20% by not doing early execution, but you prevent yourself from debugging really complex situation, and you prevent yourself from like embarrassing when stuff is shipped like immediately, and like why the hell I use default in the first place. So I'm like, and at the same time we allow implementation and like people who want to squeeze like with 20% stuff by doing early execution, we allow them to say like, yeah, I'm checked like all my resolvers. There is no interlocking. I'm sure like HTTP connection limit is not hit under like heavy load and everything else. I'm like sure with it. and maybe like they can enable like a flag or use alternative executor or like do whatever they want, and they're not breaking the spec. I'm just saying, like, if we want to keep a complexity level, even in your implementation, we need to factor like when you pass priority inside the resolver, you need to track it in every resolver, and we need to explain these concepts to GraphQL newbie, the like guy who start like server about GraphQL tutorial. We need to include like part explaining what's priority in resolvers, and like also your box saying like you cannot like batch or interconnect without priority, stuff with different priority levels. You cannot like even explaining that is complex, and I would say most people, like in 90% cases, they would prefer to have simplicity and lose like little bit performance, and instead of like have little bit more performance, but like suddenly you need to learn new concept and track it and have like all libraries that you use to understand like priority levels. I'm like,
I'm not. I mean, I agree with you that it is definitely a new concept. It's sort of a new concept that flows from the promise of GraphQL and concurrent execution. I think it's like akin to what we could, I think the first problem, or maybe not the first, but one of the first problems that people come across when building GraphQL servers might be, depending on how they build it, might be like the 1 + n or n+1 problem. And then they're immediately presented with data loader as a handy solution to that. I mean, I think it's akin to that, like because of the design of GraphQL, of incremental delivery, we have concurrent execution there for you to maximize performance, but you need to be aware, but in the same, so I do think it's a new concept. But I mean, my main concern is sort of like a utilitarian one, frankly. I think Benji makes a good argument, or he made offline to me. I can't recall if he put it in print, but I think I agreed with it where we had that discussion, which is that the spec should really match the reference implementation. And I know a long time ago, or maybe not so long, depending on your frame of reference, Ivan, we had a whole question about how much GraphQL.js should differ from the spec. But I do think in this is a pretty big difference to have early execution not be in the spec, but to have it be in GraphQL.js. And from what I recall, Benji was arguing that they should be the same, and I kind of think also they should be the same. But I do want to make early execution an option for those people who want it. So that's kind of where I fall out, that because I don't necessarily think that for sure it should be on by default, at least when it's publicly released. I think in the experimental stage, when we're releasing it for people to play with it, I think we might want to encourage people to use it so we can see if it's actually a problem in the vast majority of cases, sort of mess with people in that way to, let them perform a natural experiment for us. But I definitely would want it out there in GraphQL.js. And because of that, I would want there to be spec language that clearly lays out how it works, alluding to what Rob was mentioning before. So that's not necessarily the best argument, but that's sort of my, what it boils down to for me.
I'm personally think for the same reason I explained, it's also a problem in GraphQL.js. It's like you need to understand what you're doing. I'm like, I work in C++ for a long time with like multi-threading, and even for professional programmers, it's hard to understand like how things interconnected or like what resources are shared. And Benji's example about HTTP connections or like other resource pools, I would say it's like it would be tricky, even if we just have GraphQL.js without like Stack at all. I think it's like saying you need to track priorities explicitly and like constantly thinking, are you like tying resolver execution to something with to another call? Like it's not only happening in resolvers. Imagine you calling some other and use something or batch something. You, for example, would be like data and database, and let's try to be like optimizing something. Unless you go inside like this layer and be sure that nothing is like tied there, logged there, like interconnected or batched, you cannot be sure. Yeah, so I'm skeptical even about GraphQL.js. You cannot audit like like all the libraries you're using. Let's say like you have arguments that this interconnection maybe they're not harmful, but we cannot produce widely used libraries assuming edge cases is like, yeah, I'm like, from API design perspective, I think it's like we should go wait deferred execution both in GraphQL.js and Spec by default. So maybe we'll in GraphQL.js, maybe if people will request it and like benchmark why it's really important in that case, maybe we will enable like a flag or something. But by default, I think it should be default execution of.
If that's the default, I really think that we need like a global way to opt out of it, and then maybe a resolver local way to opt it back in. But I would really hate to like say you have to have this penalty of deferred execution if when you know that this resolver is like that is not going to be affected by it, and then there like once it's deferred, there's no way to undo it. If you know that your code isn't susceptible to the problems, then and not having a way to, yeah, I don't know.
In this case, you need this mechanism to say like particular result, because like people do modular like resolvers potentially can, I don't know like how widely it's done, but some companies use handwritten API GraphQL gateways when they like each team maintain like particular directory with like their own resolvers. So like if we want to do something, yeah, I'm agree like in ideal world, we would say we would have like some kind of resolvers to say like, this resolver, this particular resolver is fine to be called earlier.
Yeah, I think we may one day, so meaning with this feature, I think we might, want to declaratively sort of label which end resources a resolver uses, and pave the way toward more advanced query planning. I mean, again, I think overall, I think a lot of, to sort of quote from what Benji dumped into the chat that I see, he's suggesting that defer is, in his opinion, a replacement for issuing a GraphQL result, waiting for the result, and then querying additional GraphQL data based on the result. I don't think I would disagree with that. I just would think that it's overall. I mean, you can still do that's still always an option to you, and so it's not. I'm not sure how much of a benefit defer would be to clients. To that option. I mean, you can have client-side deduplication. What we're doing in terms of deduplication, you could do client-side. I thought that early execution was actually one of the main features, not the primary feature. Obviously, that was increasing the speed of the initial result, but I thought it was the main features because you could always increase the speed of the initial result just by sending separate requests, and that option is still always available. So I'm not, I thought that this balancing act between increasing the speed of the initial result and providing, total, decreased total result time was basically the main benefit. So, I still, I think if we have a global, I think we're already basically seeing that people are requesting this feature. I mean, the main driver, Rob, here of the champion of this feature is asking for it. So I think we already have like people asking for it. So it's hard to say that we wouldn't entertain at least releasing it on or at least exploring it on an experimental basis. And since the entirety of Defer and Stream is still experimental, I kind of really want to get it out there and see what actually the real world impact is, and have people start experimenting with it with GraphQL JS or any other implementation. So that we can get a sense of what the best way is to move forward in terms of whether it's too difficult to use, whether it's it should be included but enabled under a flag. So I don't know. There's my 2 cents. I think it's a pretty important feature.
One clarification: even with deferred execution, you still have like performance benefits. You're not calling intermediate resolvers. So like you have like intermediate fields, and even if you defer in execution, like one query is faster than 2 separate queries. So defer is beneficial because you're not doing database lookup from photo level field from. So I think this is like major saving in defer case. And I'm kind of like, if we feel strongly, I'm okay with experimental. One thing I'm worried about, I'm okay, like if we keep this open, put like a label saying we should discuss it one more time before releasing GraphQL JS as extremely defer as non-experimental feature in GraphQL JS, and definitely before we match it to spec. And here, just to do experiment, one caveat I'm worried about: how we like get feedback. I think like most of people that will try stream defer, they will not do like deep performance metrics, and especially on experimental stuff. In like hobby projects, demos, or like trying to run something small. Like how we plan is people like will really debug this issue and report it as if we do like if we will have this feature for like months. If we will have it for years, years, right? Somebody will discover it and say, like, in my particular case, it's like problematic. And another argument, if we do it like early execution by default, people will learn about it and they will think like solution. Yeah, I'm kind of like I'm kind of partly skeptical about we getting real feedback about it in like short running experiment. Like in experiments, they will in features that mark as experimental, and it's pretty complex thing for person who just try extremely differ.
I'm not sure if that's what that's what I meant. I mean, I would think that we could release it before the spec change is finalized, early execution, I mean, and I think it would then be adopted. You know, as we saw already, clients would then try to match the new format, but the new format's not going to change based on early execution and deferred execution. And then they're going to start, you know, even large schemas and popular schemas with lots of clients would probably test it and help us out.
Yeah,
in that sense. I think
so
a popular technology, and I'm not sure that we wouldn't. I'm not sure. Maybe I misunderstood. I'm not sure why we wouldn't get some feedback that it's not working as expected. And if we don't get that feedback right away, even if those edge cases exist, I think because we've identified this issue early, it should, you know, we should be able to educate around it. I mean, it's potentially one of the, you know, major issues with this new feature. Potentially a confounder, but potentially not. So I think it would have high visibility about it.
So like to put in perspective, for example, we need to, since we know about data loader for sure, and people using data loader also for sure. So we need to release experimental feature in data loader because, like for example, we decided it's a bad idea. So
the issue with sorry, 1 second. The issue with data loader is specifically only if you're doing this version of it. It wouldn't be a problem if we did version 2, which is where deferred fields they're not deferred entirely until all the other resolvers are done, but they're delayed by 1 tick or something, right?
No, the issue, well, in a later tick, there could be, by chance, it could be that in the same tick, something from lower down in the query of the initial result happens to coincide with the same tick of that deferred result. So that's what I'm saying. I'm not sure. I think we really need to have a real world experiment to see like how often does that happen, and even when if it does happen, does it overall maybe improve the overall effect for the client? You know, because you have, you know, a batching between the initial and deferred. We don't know even that necessarily, presumably it will be slow down the initial result to some extent, but we don't know how much, and you know, and in which majority of, you know, which kind of cases. But in theory, it could happen even if it delays an initial tick, you know, sort of by chance, if things are on the same tick later.
It's also not uncommon to use data loader more than once in the same resolver.
You don't need like multiple usage of data loader, and you know, like you have, for example, end user and friends. and friend is the same like as user. So if you're accessing the same type through different intermediate fields, you can have situation where stuff like coincide, basically.
But it would have to be, if I understand, even in the same resolver, or even like, again, if it's the same object, it would have to be that the first to mean that the ticks match up, and that isn't isn't a necessity. It's possible that the ticks will match up, but in my mind, it seems somewhat unlikely.
So a question here, like, if you give me a schema using data loaders, my claim is that I can construct a query that will entangle initial result to default part. Like whatever schema you give me, like with resolvers using data loaders, I'm as attacker, non-attacker, like I can construct a query. This query can be like rare, or it can be like popular. And also another thing, sometimes it can happen unpredictably because some code in intermediate resolvers or resolvers can be like optionally asynchronous. For example, cache. If you have a cache, you get something synchronously from cache. If you're not, you like doing something asynchronously. And because of that, ticks can shift and like interact or non-interact. It would be hard to debug. But my claim is that with queries that tangle initial response with default part, it's possible in any schema using data loader now, among other like use cases that Benja pointed out. Like in high performance servers, like HTTP connection limit can be like a thing. If you have like a beefy server with like a lot of CPUs.
Yeah, I mean, again, I'm definitely not disagreeing with you. I think there could be entanglement, and what I'm arguing is that I'm not sure to what extent overall that's going to lead to problems. And sort of by definition, I'm saying it could be unacceptable. I guess what I'm saying is that we've given solutions where developers can solve those problems using either disabling it on a per field basis or using exposing the priorities so that they can then have separate data loader queues. They can even optionally, not have separate queues for every priority level, but just the initial results versus everything else. I think that's easily teachable and easily generalizable. And so overall, I think this is a feature that I would push for. I think it would, the question in my mind is only the timing of when to push for it. Do we say that first we release defer with delayed execution, and then we push for changing the spec and changing GraphQL.js simultaneously to allow early execution? Now, all of these mitigations are going to be not actually within the spec because they're very much tied to the implementation. They involve the info object, the context, data loaders, which are all not in the spec. So in my mind, I think it would be beneficial to release both of these, sort of as an educational tool, to release both of these simultaneously. The early execution and defer, and just provide the mitigations and tell people they could disable it if they want on a global level, but by burying for a later potential, for burying this feature until a later release, I don't know, let's say in another year after defer drops, And then I think we would have to argue that we would need to change the spec to handle the how we do filtering, et cetera, just like we're suggesting now, so that GraphQL.js could have this feature, even though when it's sort of lined up ready to go now, I don't know, it doesn't seem to me the best way to go. So again, I would vote for experimenting, getting some real world data by releasing it as is, and then we can always pull back if that doesn't work out.
To
we're
move
way-
forward, yeah,
we're way over
we
time.
over time. I can suggest like steps that can untangle it to extent. So like we cannot release it even as experiment without providing solution, right? It's bad. Like we recommend data loader as solution to stuff. We release like experimental implementation of StreamDefer, and like so maybe Yakov, you as a proponent create PR to data loader, add these features there, have examples that shows that data loader can work with priorities, and you try if it's hard or not for people to use how like API will look like. Because like my position, we cannot implement it without showing how people can use it together with data loader.
I'm not sure I agree with that. I mean, I think we released GraphQL was released without data loader. So I'm just not sure overall if I agree with that approach. I mean, I can try to work on it, but to me, like the way in which these queues would want to be managed might depend on the resource. But I mean, it's not like fundamentally I'm against improving a data loader. I mean, I already posted in the chat. There's a generic resource manager, not in the chat, on the discussion, that sort of provides this already. I don't necessarily feel like I can rewrite that priority queue library better than they did. So I think the solutions are already out there. I mean, I can try to write something GraphQL specific, like zero dependency, if that's deemed necessary, but I don't think we should deem it necessary.
In like, okay, maybe not as data, but we need to provide upgrade path. So
Yeah,
basically,
I have to go too.
Yeah.
So
yes, sorry.
yeah, let's
Continue.
wrap up. Benji left a good comment. I'm going to add that to my notes. Yeah, I think that we should get more. I think we should probably talk about this at one of the main GraphQL working groups. Maybe I'll put it on the agenda for the first one in July. See what everyone else's thoughts are. But yeah, I have to sign off. So, any last thoughts?
Thanks, Rob, as always. Thanks, Ivan, for your feedback.
Yeah, thanks everyone. I wrote
Yeah.
my last thoughts in the chat if anyone's interested.
Yeah, thank you.